Welcome to This Explainer. Today, we're jumping right into a genuinely shocking discovery about Africa's water resources, and we're going to unpack the complex reality behind the headlines. If you follow global water security at all, you know that surface water scarcity is a massive concern. But new data is forcing us to completely rethink the map. When we picture certain parts of the African continent, we usually think of severe water scarcity, right? And for good reason. Surface water there is often unreliable and heavily impacted by climate change. But what if there was an ocean of fresh water sitting right beneath their feet? What if the crisis wasn't about a lack of water, but rather about where it's hiding? The numbers here are absolutely staggering. Scientists have mapped an estimated 0.66 million cubic kilometers of groundwater underneath the continent. To put that massive volume into perspective, that's more than 100 times the annual renewable surface freshwater found in all of Africa's lakes and rivers combined. It's roughly 20 times the average annual rainfall for the entire continent. Section 1. Africa's Hidden Ocean. So where exactly is this phenomenal volume of water located? Well, the distribution is incredibly uneven. The biggest reserves aren't where the rain falls heavily. Instead, they're situated deep underground in North African countries like Libya, Algeria, Egypt, and Sudan. Basically, they're sitting right under the Sahara Desert. We are talking about massive sedimentary aquifers holding ancient water at depths of 100 to 250 meters below the surface. Section 2. The accessibility trap. Now you might be wondering, if the water is right there, why don't we just pump it out and solve the global water crisis? Well, just because the water exists doesn't mean it's easy or wise to access it. The reality reveals a stark contrast between the feasibility of small-scale hand pumps and the immense technical barriers of large-scale irrigation. You see, large-scale agriculture demands massive, often unsustainable yields, sometimes needing over 50 liters per second. Small community pumps, on the other hand, only need a fraction of a liter per second to work beautifully. For local communities, a simple hand pump yielding just 0.1 to 0.3 liters per second is highly feasible. And here's a really fascinating scientific twist. Over a third of Africa sits on low permeability basement rocks. Because the rock doesn't let water flow too quickly, it acts like a natural brake, restricting how much water can be pumped out at once. This naturally prevents localized overexploitation, essentially avoiding a tragedy of the commons situation where one massive farm drains all the water from everyone else. It's like having built-in sustainability. But scaling that up to reach the deeper aquifers, that's a staggering financial hurdle. If you want to tap into those massive Saharan reserves, you have to drill deep. While a hand pump in the Democratic Republic of Congo might run up to $13,000, drilling a deep borehole to reach water below 100 meters requires some highly sophisticated rigs. That cost can skyrocket to $130,000 each. It's really not as simple as just drilling big boreholes and watching fields of crops magically spring up. Section 3. The danger of over-extraction. Let's say nations do find the capital to extract at those massive scales. Well, we run right into some severe ecological dangers. Much of the deep water under the Sahara is what we call fossil groundwater. This is an absolutely vital concept to grasp. It means this water was deposited thousands of years ago when the climate was totally different. Intensive extraction is essentially mining a non-renewable resource that will not be replaced by modern rainfall in any human timescale. Once it's gone, it is gone for good. Sure, large-scale pivot irrigation projects can create sudden agricultural booms and literally green the desert. But unconstrained pumping quickly exceeds those long-term natural recharge rates. When that happens, the water table drops, the cost of pumping goes through the roof, and the local ecosystem begins to fracture. This over-reliance leads to degraded water quality and devastating ecological damage. And honestly, it serves as a stark warning for the broader global water crisis. Across the globe, when we overpump, we see falling water tables that dry up surface wetlands. We see existing fresh water turning salty. We see excess fertilizers leaching into the groundwater and contaminating it for decades. We even see physical damage to the earth itself. Take Mexico City, for example, where the severe overexploitation of groundwater has caused dangerous land subsidence. The ground is literally sinking beneath their buildings. Section 4. The political challenge. Beyond the environmental impacts, managing this hidden ocean is an incredibly complex political challenge because, well, water doesn't respect maps. For example, let's look at Libya's Great Man-Made River Project. It's an engineering marvel that cost a mind-blowing $20 billion to pump fossil groundwater for its citizens. But this massive extraction doesn't just affect Libya. Experts note it has already begun reducing groundwater levels across the border in Egypt's western desert, making it much more expensive and difficult for Egypt to access water on their side. And this brilliantly illustrates the core geopolitical issue. As hydrologist Mohammed God points out, transboundary cooperation is absolutely vital. Because these massive underground aquifers cross multiple borders, they're shared by countries like Algeria, Libya, Tunisia, Egypt, and Sudan. Managing them is a geopolitical necessity. Unilateral massive extraction by one country directly threatens the water security of its neighbors. Section 5. Sustainable alternatives. So with deep extraction proving so financially costly, ecologically risky, and politically fraught, what are the sustainable alternatives? How can the continent actually achieve water security? Well, experts strongly advise against treating these deep aquifers as a magic bullet. Instead, we need to focus on careful local hydrogeological monitoring and prioritize those resilient, small-scale roll pumps. We have to tightly control agricultural fertilizer use to protect the water quality we currently have. But perhaps most importantly, we need to look to above-ground alternatives to secure long-term sustainability. A major alternative here is rainwater harvesting. The United Nations Environment Program actually found that there is enough water falling as rain over Africa to supply the needs of an astonishing 9 billion people. To give you a specific example, in Ethiopia alone, the potential rainwater harvest could cover the needs of over 520 million people if it were properly collected and stored. The problem isn't a lack of rain, it's a lack of collection and storage infrastructure. Which brings us to our final thought. Ultimately, the discovery of Africa's hidden ocean is a monumental scientific achievement, but it isn't just an invitation to drill deeper. It's a powerful challenge to manage our most vital resource with true long-term vision. So the question is, are we prepared to build the infrastructure to sustainably collect the water that's already falling from the sky? Or will we resort to unsustainably mining the ancient ocean beneath our feet? Thank you for joining me for this explainer, and I hope this gives you a clearer, more structured understanding of the incredibly complex reality of global groundwater.